In this video, you're going to learn about parallel circuit. And from the circuit diagram here, you can see that the two resistors, R1 and R2, they are connected in different branches. So that means to say they are connected in parallel. Now let's see how this circuit is related to the river system over here. As mentioned, EMF of 10 volt means the pump will pump the water up to a height of 10 meters. Then let's label this as point A and correspond to this point here, point A, and there's no drop in the height until this point. Let it be B1 and let it be B2 here. That means to say before it enters into R1, this will be B1 and this point here will be B2. Once it comes out from R1 and R2, let's call it C1 and C2. So here is like your C1, here is like your C2. And then the last stretch here leading back to the negative terminal of the cell, then this point is point D. Now as you can see, there are two branches here, and let it be R1 here and R2. R1 and R2 can be the same or they can be different. Since I drew this is wider, the branch here, the river here is actually wider, it means to say there's less traffic jam. The river is wider, so the water flow is higher, so the resistance is actually lower. Let's give it a value, for example 3 ohms. So that means R2, which is narrower, more jam, it restricts the flow, so the resistance is higher, for example 6 ohms. So the current flowing through obviously will be smaller. These are things that you can relate to. Next, let's go through the 3 rules. Let's start with the total effective resistance. Now maybe let's recall, if it's a series circuit like previous video, let's say this is R1 and it's 3 ohms and R2 is connected in series 6 ohms. To find the total effective resistance, basically you just need to add both of them up, 3 plus 6, that will be 9 ohms, and you realize that the total effective resistance will actually be much higher. But for parallel circuit, okay, the rule to find the total effective resistance will be 1 over RE is equals to 1 over R1 plus 1 over R2. If there are more branches, you just continue to add on. Or another way to represent it will be RE, total effective resistance, is equals to 1 over R1 plus 1 over R2, and you invert the whole thing. So they are the same actually. So maybe perhaps we just solve this. If for this case, the two resistors R1 and R2 are connected in parallel, let's use this method. 1 over RE equals to 1 over 3 plus 1 over 6. That will be 1 over 2. But bear in mind that is not the total effective resistance. I want RE, not 1 over RE. So I have to do the invert. It becomes 2 over 1, and therefore the total resistance for the two resistors in parallel is actually 2 ohms. It actually makes the total resistance smaller than any one of them. Now let's take a look at the current. If the current coming out from the cell, okay, it will flow here and let it be I0, and when it comes to this point here, it will split. Let it be the current I1 flowing through the R1 branch, and this is I2. Now I hope you can still remember the branch, the current flowing through R1, there's only one path in which the current can flow, so the current remains the same. So this side here will still be I1, and for this branch here, it will be I2 throughout, and then they will join back and then form I3. Now if you want to better understand, let's take a look at the river system. Coming out from the pump at 10 meters already, this is like the main river, and the current is I0, and it stays the same. The current will be the same throughout until at this point here is correspond to the junction over here. That's where the water will split, the current will split. So because this is your branch R1, that will be my I1, and you know by looking at the diagram, the current I1 will be greater than the current in I2 because it's wider, less resistant, more current flow. And then you look at the bottom of the point C here, the two small rivers is going to join back, and then this part here, it will be I3. So one look at this diagram, you can actually know that the I1, the big river, and the I3, the big river at the bottom, they are actually the same. Only when it comes to this point here, it will split into two smaller rivers, and then they join back again. So the relationship will be I0 is equals to I1 plus I2. That means the sum of the two current in the two branches, and when they combine back, okay, when they combine back, that will be equals to your I3. And if you want to, what's the current flowing through the battery, it will be the same also. Okay, that's the main river. Lastly, on the potential difference. Now maybe for this case, let's state the rule first. So because as long as they are in parallel, the potential difference must be the same. That means to say, let's assume here is V1 and here is V2. Because they are parallel branches, the potential difference must be the same. So V1 must be equals to V2. But for these two resistors in parallel, they happen to be parallel to the EMF. That means to say, if for this case, it will be equals to the EMF. So all of them will be actually 10 volt, potential difference of 10 volt over here. But to better understand the concept, let's consider the river system. As mentioned, you already rise up to a height of 10 meters. So from here onwards is 10 meters, 10 meters until this point at point B, it will still be 10 volt, 10 volt. So all the way here, all these will be 10 volt because it's just copper wire. There's no drop in the voltage, no drop in the height. On the other hand, here at the bottom from C to D, you can see is ground zero. So this will be 0 meters, 0 meters. On the circuit here, you can see that this is 0 volt, 0 volt. And even at C1 is 0 volt. C2 here will be 0 volt. So once again, if you find the voltage difference, 10 minus 0, that's why you say that there's a potential difference of 10 volt. And likewise for V1, you find 10 minus 0, the potential difference across this branch will be 10 volt. So if you refer back to the river system, over here at point B, this will be 10 meters, and at point C, this will be 0 meters. So that means to say there's a height drop of 10 meters or a height difference of 10 meters or potential difference of 10 volt. So regardless whether R1 and R2, whether they are the same or different, as long as they are parallel branches, the potential difference, the height difference will be the same. So this will be the three rules for parallel circuit.